in your calculator, I'm hoping that you notice some symmetry. Okay? There's two types of symmetry that can happen. We can have horizontal symmetry or we can have vertical symmetry. And it all depends on which type of an equation we have. If we have a sign in our equation, what variable do we typically associate sign with, like on the unit circle? Y. And Y we associate with vertical. Okay? So when you have a sign function in your equation, you are going to see some vertical symmetry in your graph. Whether it be a circle, a rose, or a limacon, which is the three types of graphs you're supposed to kind of look at on that worksheet. Okay? If there's a sign in your equation, you're going to have vertical symmetry. On the flip side of things, if you have a cosine in your equation, you should see what kind of symmetry? Horizontal. Okay? Now, I say polar axis, that's what we call, we don't call it the x-axis because we don't have x's. All right, so you can either call it the horizontal axis or the polar axis. Okay, the first kinds of graphs I had you play around with in your calculator were circles. Okay, and the circles went through the pole. Okay, what I want to talk about is how we know where our circles are going to be. Okay, now first of all, we've already talked about these kinds of circles. R equals A, R equals 4, R equals 5, whatever. Where are these circles centered at? The origin. And A is representing what? The radius. Now, we had two other types of circles, and they looked like this. I'm going to give you 60 seconds to discuss with your pod what these circles looked like, if you can remember.
It just looks like this. I graphed it. I just don't know how it's right. It's like it's shifting. Thanks. I dropped flowers like 3 times.
All right, let's talk about these circles. Austin, if we have A cosine, R equals A cosine theta, what's going to happen with our circle?
It's going to go to the right.
It's going to go to the right. And how far to the right is it going to go? Okay, A. So A, in this case, is representing our diameter of the circle. Okay? We have cosine, so we know we have to have horizontal symmetry. Since A is positive, it's going to go to the right. What happens when A turns negative? Okay? We're going to go to the left. Okay, so if you have a positive A R cosine theta, R equals a positive A cosine theta, our circle is going to be on the positive side of the pole. If we have a negative A, it's going to flip to the left, where we think of as those more negative values. Okay? So if we have cosine, our circle's going right or left. If we have sine, where's our circle going to go? Up or down. A positive A will make that circle go above the pole, and negative A will force that circle to go below the pole. Okay? But A is how far we're drawing that circle out, so A is representing our diameter, which is different than the first circle we talked about, centered at the pole. Okay. We're going to graph one circle, and then I don't feel like we really need to graph any more than one circle. These are the easy graphs. Okay? When you have worksheets for me today and tomorrow, this is what they're going to look like. These are the things that I'm going to be asking for. So go ahead and just write r equals -5 sine theta. And then we'll fill this in as we go. I don't think that you need to draw, you can just draw like an x, y axis. Hi. Yeah. Did I not give them to you? Yes, I did give you. Yeah. Yeah.
I just want to make
They're
sure you
pink.
had them reversed out.
Yeah.
Oh, yeah.
They're both pink. Yeah. Whew.
Sine.
Okay. So, when I ask for the shape, what are you going to tell me? Circle. Okay. The max R value. What's the furthest from the pole we're going to be? 5, because that is representing our diameter. So that's the furthest away we're going to be. Okay. Number of zeros and zeros, we'll get to that in a little bit. Okay. We know that R equals -5 sine of theta is a circle with diameter 5. Where at in relation to the pole? Up, down, left, right? Down. It's sine, so it's going to be up or down from the pole, and since A is negative, this circle is going to sit below the pole. Okay? So we know it's going to be right here. Okay? But in order for us to think about how many zeros this has, I want us to think about some points. So if I plug in 0 for theta, what do we get for R? Thank you. And if I plug in pi over 2 for theta, what do we get for R? -5. So at pi over 2, we go -5. Okay, and we can draw our circle, right? Okay, now, we start here. Is that circle-ish? Circle-ish enough?
It is for math.
We're going to go with it. That was terrible. I'm going to. Okay. Now watch. When we talk about zeros, we talk about where our graph hits the pole. So do you see how I start at the pole and I draw my terrible circle and I end at the pole? Oh, that's pretty good. That was pretty good. Whatever. Okay. So I started at the pole, I drew my circle and ended at the pole. How many times was I at the pole?
Twice.
So we have 2 zeros.
Look at my
Okay, we're just getting warmed up. I'll be better by 7th hour, right? Okay, well, how do we actually find the zeros? Okay, when I ask you for zeros, I'm asking you for where we are at the pole. Well, what is the R value at the pole?
0.
Hence the name 0, right? So when we set our equation equal to 0, we are finding our zeros. Okay? So where is the sign equal to 0? Well, we know the sign is equal to 0 at 0, but I want 2 zeros, so I'm going to name the next place pi. But I only have 2 zeros, so I'm going to stop there. Yes. Okay. We got the number of zeros because I plugged in theta is 0 and I knew I started here. So I started at the pole, ended at the pole, so we had 2 zeros. Okay? So to find the zeros, we just plug 0 in for r and solve. So I divided the -5 over, and I have sine of theta equals 0. Well, I know that happens at 0, and I know that happens at pi, and I know that happens other times, but I only wanted 2 numbers, so I stopped there. Okay. All right. I think the first question, you might have 1 circle, you might have 2 circles on your homework. But what I'm the most concerned with you graphing today are the rose curves. So I'm going to give you about 60 seconds to discuss what you can about rose curves, any of your observations before we officially put them down on paper. Okay? So this is like the top of the back side. What is A? What is N? How do you know what? Go.
Yeah, I wrote A. Yeah, basically. Yeah.
Okay, so let's talk about the most obvious first. Okay, we're going to have r equals a cosine of n theta, r equals a sine of n theta. We've already talked about that we will have horizontal symmetry with the cosine equation, and we will have vertical symmetry with the sine equation. Okay? What else will happen, and we'll see this as we do some examples, but when we have a rose curve that involves a cosine, we are going to begin on the axis, okay? While if it involves a sine, we will begin at the pole, okay? So those are some observations that you'll make as we do some examples, but I'll come back to those and how that's going to affect some of the things that we find. Okay, let's start with A. What does A help us figure out?
Max height.
Okay, since we are talking about what we call rose curves, they look like flowers, right? What are we going to call those loops?
Petals.
Petals. Okay, so A, we're going to call the length of our petals. When I ask you for max R value, okay, that's what Riley just said. When I ask you for max R value, it's going to be the length of the petals. Okay? N. What does N help you determine?
The amount of petals.
Okay, is it as straightforward as there's N petals?
No.
No. Okay? It matters if N is even versus N is odd. Okay? Okay. So which one is straight up N petals? Okay, if N is odd, we have N petals. Okay, what actually happens is it's going to go through and draw those N petals, and then it's just going to trace over it again. Okay, so you don't actually see all of the petals because they overlap, so it only looks like n petals, okay? As opposed to if n is even, we're going to have double the amount of petals, okay? Since that's the case, it's going to take twice as long to draw the even number of petals than if we have odd petals. What do I mean by that? Okay, if you have an odd number of petals, it's only going to take you from 0 to pi to get all of your petals drawn. However, if you have an even number of petals, it's going to take you from 0 to 2 pi to get all of your petals drawn. That's really not going to affect you too much, except for when you're finding your zeros, you're never going to have zeros past pi if you have odd petals, okay? But if you have even petals, your zeros will be from 0 to 2 pi. Okay? We're going to go through a couple examples because each graph is a little bit different. We have some things to think about. We have like the horizontal versus vertical symmetry that will affect our zeros. We also have the number of petals that will affect where they go. Okay. What I'm going to do is I'm going to teach you how to find where the first petal goes. And from there, just use symmetry to draw on your curve. Okay, I'm not going to ask you to plug in a lot of points. I'm basically going to ask you to plug in 1 or 2 theta values and use symmetry to draw the rest. Okay, did you notice how your petals were all evenly spaced, right? If you had 3 petals, they weren't like all next to each other. They were evenly spaced apart, okay? We're going to use those to help us. They're kind of pretty, right?
Yeah.
Yeah?
The 3 or 5.
Did I ever make you graph something with a lot of petals?
No, but I did.
Well, you did it anyway? Okay.
Just to see.
Okay, so what I'm going to do, I'm going to have you write this down. And then I want you to draw the graph here. And if you only want to draw in like 0, 90, and the 45-degree angles, that would be enough for this graph. But you need to draw at least this blank polar coordinate graph for me. Okay, so write down the equation and get this drawn in. Okay. Ooh, you know what, guys? Can I change my mind and do this one first? Okay. You're not going to have to erase too much, but you will need the 30 and the 60-degree angle marks. So you'll need all of it. But cosine ones are a little bit more straightforward. Let's start with that one. I apologize. Yep, draw the circles so you know like how far. I know. How many circles should we draw? I would draw 5. Bear with me through notes, and you get a worksheet where all of these graph grids are given to you. So I just need you to have it for your notes. Okay, so you make sure you have the 2 30-degree marks, the 2 45-degree lines, and the 2 60-degree lines. Raise your hand if you need a little bit more time. Okay, you like 30 seconds? Is that enough? Okay, while we're waiting, how many of you got to see Endgame this weekend?
Oh,
You seen it tonight? Okay. Okay. All right. No spoilers. No spoilers. All right. I know. I don't think I'm gonna get to see it for like another week or two. So here we go. When I ask you for shape, we can recognize. Okay. I want to point out the difference between a circle and a rose. There's a coefficient with theta, right? So I see this coefficient of theta. I know it's a rose. I would also like you to tell me how many petals. So n is odd, which means we have n petals. So we are going to have 3 petals. Okay, Dallas, how long are the petals going to be? 5. So our max R value is 5. This coefficient out here is going to tell you how long the petals are. Okay, much like in our circle, it told us how big our circle was. Okay, all right. So what I'd like you to do is I want you to jump down here to significant points. And on the worksheet you're going to do tonight, you're going to have 1 or 2 of these. Okay, you're not going to fill out a whole lot of significant points. You will always put 0 in for theta. Well, what happens when we put 0 in for theta? We have 5 cosine of 0, which would be what? 5. So I know that at 0, we're at 1, 2, 3, 4, 5. And from here, we can draw our curve. For real. Okay? There are 360 degrees around this circle. We have 3 petals. Riley is suggesting we divide that by 3. If we take 360 or 2 pi, I don't really care, and we divide it by 3, then our petals are going to be 120 degrees apart. So here at 120 degrees, I'm going to make a dot, and then 120 degrees later, I'm going to make a dot. There are my 3 petals. And now we can connect the dots to make our, now don't do it yet, okay? So let's just review. I know where my first petal is. I took 360 or 2 pi, divided it by the number of petals, so I would know how far apart they are. Now, everybody watch me draw. This is where we're beginning. I want you to pay attention to how many times we go through the pole.
2, 3. Man, that looks so.
We have 3 zeros. Go ahead and try yours. You have to start with theta equals 0 and then draw your petals.
Can't even like see the petal because of how.
They're really fun to draw.
Yeah.
Okay.
Can you see my petal? I can see some shapes.
Okay, now you told me we went through the pole 3 times, which is why I wrote we have 3 zeros. Okay? Now, we have to actually find the zeros. Okay, we find our zeros by setting our equation equal to 0, just like we would with rectangular coordinates. Okay, when we divide that 5 over, we have 0 equals cosine of 3 theta. Okay, now we know where cosine is 0, all right, but look at our angle. Our angle is 3 theta. Okay. So 3 theta equals, where is the first place that cosine is 0? Pi over 2. Then 3 pi over 2. we said that there's 3 zeros. So we better keep going until we have 3 numbers. So if we keep rotating, so cosine is 0 at pi over 2. We rotate down to 3 pi over 2. We would rotate up to 5 pi over 2. Then, to solve for theta, we would divide by 3. So our zeros occur at pi over 6. 3 pi over 2 divided by 3 would be pi over 2. And then 5 pi over 2 divided by 3 would be 5 pi over 6. Addison. Here? Okay, so do you see how it says the cosine equals 0? So 3 theta is my angle, I wrote it there. And then these are the first 3 places where the cosine equals 0. Okay? If I had 5 zeros, we would have had to rotate until we had 2 more numbers. Okay? You keep listing off where cosine is equal to 0 until you have the number of zeros necessary. Okay? Do you remember me saying when there's an odd number of petals, then your flower, your rose gets drawn from 0 to pi? Notice how our zeros are between 0 and pi. Okay? Any comments, questions, concerns? Excitement? I know, you do.
Jinx.
Okay, so let's go back to the one I wanted to, that I skipped over. Okay, I'll give you a couple minutes to write down the equation and then to draw this set of concentric circles. I will tell you, because I know what the graph is going to look like, you only need the 45-degree angles, and you would only need 4 concentric circles. Okay? Circles with the same center.
I know, this makes me feel smart to say it.
You're going to walk around talking about concentric circles. Maybe we can just write it in the
That's how they talk trash. You're only in algebra 2? That's what they're saying out there.
Circles in there. We'll just flex our average team GPA.
Oh, yeah, that's pretty
Is he getting bald yet? No, he's not getting that cut off. No, I was using it as a way to judge how many people's ACTs know yet.
Did he tell you that?
No, it's just that once he goes bald, I'll know that we hit an average. A high average. So.
Did he tell you he was going to say?
Yeah, we had to improve the average score by like, what? Half a point.
Oh, yeah, we have to.
So if he goes bald, then I know that the last 12 schools.
Why is that there?
Huh?
Because then Mr. Brown will check
What?
out his head.
There's a rumors for everything. But it's not Tuesday. Why does that matter? It would be weird if it came in like, what, it's been 3 weeks and 6 days?
You have a
Yeah,
calendar?
okay,
That's
okay.
not
We took the
I'm not on results. It's in 5 to 8 weeks.
Oh.
That's dumb. But that's what the other ACT told me, and I got mine too. So,
Okay, does this mean we have our grid drawn? Anybody need more time?
Oh,
Yeah, I know.
yeah, so did
That's like, we both get like
Okay,
X's.
so look at the format here. We have a sine of n theta. We have that coefficient with theta, so we know we're talking about a rose as opposed to a circle. And using your fingers, tell me how many petals this has. Do I only have 3 people with fingers? I think everyone has fingers in here. How many petals does this have? There are 4 petals. N is 2, which is an even number, so we double it for the number of petals. Okay? Coincidentally, A is 4, which means our petals are of length 4. Okay. All right. Now here is where things get kind of, well, they're different. Okay. When what do you always do to start your graph? You plug 0 in for theta every time. I don't care what graph it is. You will always plug 0 in for theta. Well, when we plug 0 in for theta, what's the sign of 0? 0. Which means R is 0, and we begin at the pole. Okay. Well, how do I know where to put my first petal? Is it here? Is it here? Is it here? Okay. We don't know. We're going to have to figure it out. How long are our petals? 4. So we need to figure out at which theta value is our R, that max R value. Okay. So I am going to plug 4 in for R so we can solve for the theta of our first petal. This is going to happen every time you have a sine rose curve. You're going to start at the pole and you're going to have to determine where that first petal is. Well, it's really not that bad. When we divide by 4, we get 1 equals sine of 2 theta. We know that sine is equal to 1 at pi over 2. So now we can divide the coefficient of theta over to get pi over 4. Yes?
Why did you make 4?
That's the length of our petals. So if the length of our petals were 3, we would plug in 3. If the length of our petals was 5, we plug in 5. You should always get 1 right here when you divide that coefficient over. Okay? Which means we're always going to talk about pi over 2. It's a matter of what that coefficient is to divide over. So pi over 4 is the angle that we have our petal of length 4. So we can put a coordinate right there. And now we're done worrying about significant points. We are just going to look at our graph. Now, how many petals are there? 4. So if we have 360 degrees, or 2 pi, we're going to divide it by the number of petals, which means they're all going to be 90 degrees apart. So here's a petal, 90 degrees later, here's a petal, 90 degrees later, here's a petal, 90 degrees later, here's a petal. Okay, now, eyes up here. Our first coordinate was 0, 0. We need to count the number of times we hit the pole. 1.
I got 5.
There are 5. We started at the pole, and then we hit the pole after every petal. So we started at the pole, and then there's the number of petals that we drew. So there's 1 extra. Whereas over here, we had the same number of zeros as petals because we started on the axis. When we start at the pole, we're going to have an extra. Okay? So now let's find those zeros. All right, so we have 0 equals 4 sine of 2 theta. To find the zeros, we're going to set our equation equal to 0. We'll divide that 4 over. Okay, we're looking for where the sine is equal to 0. Our angle is 2 theta. So I'm going to write 2 theta equals. We need to write 5 times where the sign is equal to 0. So the first place would be 0, then pi, then 2 pi, then 3 pi, then 4 pi. Okay. We listed the 5 times sine of 0 because we have 5 zeros. 2 theta equals all of that mumbo jumbo. So we'll divide by 2. We have 0 divided by 2, pi divided by 2, 2 pi divided by 2, 3 pi divided by 2, and 4 pi divided by 2. There are our 5 zeros. Okay. You always need to begin by plugging 0 in for theta. If you begin at the pole, you need to figure out where your first pedal is by plugging that max R value in. If you have your first pedal, like we did with this one, you can just go, right? Making sure your pedals are evenly spaced apart. Okay. In this significant points, I better see theta is 0. If you get your first pedal, that's all you need. If you get a 0, figure out your first pedal, put it there, and then you don't need anything else. Okay. All right. So I'm going to give you a worksheet. Those of you who aren't here today and you're listening online, the worksheet should be there for you to click on. It looks like you have 2 circles and 4 roses. So it's really not a long assignment here, people. A reminder, your test is on Friday. So you don't really have a lot of room to slack off this week. You need to keep up with your homework. Otherwise, cramming on Thursday is not going to be enjoyable. So tomorrow, you have these 6 graphs and your quiz corrections due. Okay. Was there anybody not here Friday?
Like, wrong. Do I have to throw it?